guys, welcome to Legion Offensive Security's YouTube channel. Today we're gonna have a brief overview on what rootkits are, and we're gonna talk about how this from one ping to gaining a root shell. So I'm gonna walk you through what the cyberkill chain is and the five phases of penetration testing and what persistence is. And with that, I'm gonna have a brief overlook on what rootkits are. So before we start, I'll just give an introduction of myself. So I am Kundigar Dwakko. I'm the founder of Legion Offensive Security, and I am also a security researcher and a rating engineer. I also like malware development. I'm just interested in it. I'm not full time in malware development. I'm mostly a application security engineer. I just like malware development because it's something interesting. It focuses on many domains, and it's interesting generally. And you can find all my details in the all my links link. And these are a couple of certifications I have currently completed, starting with CPTS, CWS from Hack the Box, PT1 from Try Hack Me, EJPT and CRTA from EJPT from IAD Security and CRTA from Cyber Warfare Labs, and everyone's basic cybersecurity certification, the Google Cybersecurity Certificate. And yeah, so that is a bit about myself. So yeah, why don't we get into the cyberkill chain? Okay, so the cyberkill chain. So this is mostly like a framework that is used in red teaming. So I'll give you a walkthrough on each of these stages. So there are 7 stages, starting with recon and ending with actions and objectives. I'll give you a hypothetical scenario on how each step works. So starting with recon is like, okay, in the hypothetical scenario where you're performing a red team engagement on a particular organization. What you're gonna do in the recon stage is you're gonna figure out who works there. What do they do? Is it like a tech savvy organization, or are they mostly into like the business side of things? Do they not know what the tech side of things are? And also we might look into, let's say, if they are into a beta development from there, and like what are their tech stacks, like let's say MERN, C Sharp, .NET, whatever. And we'll also try to look into the people who work there. Are they tech savvy? Are they old? And get a basic overview. So in this hypothetical scenario, let's say organization A is not a very tech-savvy organization. They do not have any EDRs or any AVs. They just have Windows Defender. And most of their organization's activity directory contains, let's say, pirated softwares. And it's just a total mess. That's all I did with that. With that information, also, if I did not mention, the people working there are in their mid age, like 40 to 50 or 50 to 60, within that age range. So you can just get an idea on how tech savvy they might be. So with that reconnaissance, we might go to the next step, that is weaponization. So how are we going to weaponize this information? So let's say they don't have any EDRs, they do not have any AVs, they do have Windows Defender. That is just the basic level of security they can have, and they also have people from the age of 40 to 60. And what we can do with this information is we can plan out how we're going to go to the delivery step. So in this hypothetical scenario, we're going to, let's say, take this organization and we're going to run a phishing simulation on the organization. Phishing campaign, actually, not simulation. Simulation would be the trading side of things, but then phishing campaign. So what we're going to do there is we're going to find who works there, find their corporate email addresses, you know, regarding, like, let's say, depending on their geographical location. Let's say if they're in Sri Lanka, we're going to ta- send a phishing campaign. Let's say if this was around April, we're gonna have our Udutsu in April, and we want you guys to sign up for this. Use your corporate emails and your passwords, so we can get, you can get registered. The end goal of that is to either get access to their login credentials, or we can just send them a PDF. I think in this scenario, to explain the cyber chain, I'll stick with the PDF. And in the PDF, they just don't realize that it has a .exe extension. we're gonna just send it to them in this phishing simulation, saying, okay, this is an important document. The CEO wants this within the next couple of days. So immediately view this and please review this and let us know your details on how we should change this. So anyone in their 40s to 60s are going to be like, oh, okay, the CEO wants this done soon, so I might as well download this. Ignore anything the antivirus says. Just either just disable it and just download it. So okay, they download this and they click on this twice. That is the exploitation stage. So we have already covered four stages. So they just run it. We get the first ever, let's say, a meta shell. That is highly unlikely in a real red team engagement. But to give you a context, they double click on this exe file. We get a reverse shell. Then we go to the next step. This is installation. This is more of like the persistence part of things, where they might, we might install malicious software like malwares, rootkits, and also from there, we're not gonna stop. We're gonna set communication with the command and control center because we can't be having a reverse shell at all times, and okay, reverse shell one, what is this machine? No, we're just gonna have a command and control, and we're just gonna set up a beacon, and from there on, we're gonna maintain security and to figure out how we're gonna do things. Once that is done, in every red team engagement, we have actions and objectives. So let's say, for an example, the CEO of this organization hired us to do this red team engagement. The actions and objectives are set to do this. Objective one was accelerate all the data they can find on the financial records of the organization. Objective two, let's say there's a certain survey in the domain controller. Uh, get the files in the domain controller with the flag. They might set a small txt file with a small hash saying flag. This is the hash. Highly unlikely, but then depending on the objectives, it might change. And as a final step, they might give the objective of encrypting some kind of data. Let's say they might have a folder saying encrypt this folder, and you might have to go in encrypt that folder only. You cannot disrupt or let's say break down any services in that organization. So that is the cyber kill chain. You start from recall and you go to finishing the actions and objectives. So with that covered, I'll try to focus more on the persistence topic in the five stages of cybersecurity of penetration testing. So as I mentioned before in the cyber kill chain, we have the seven stages. In this, we have five phases, which is the same, but in this, they focus on mostly the maintaining access part of things. So that is mostly the persistence part, where you might install rootkits, you might install SSH keys on users. I'm just talking in the Linux perspective because that is what I am going to focus on today. And yeah, so persistence is maintaining access. It's not privileges. Privilege escalation might lead to persistence, but persistence is from the simplest part, maintaining access. You might create a user on a domain controller. You might put SSH keys on Linux servers. You might either, let's say, if you get access to the physical device, you might install like a malware to on the narrator exe narrator feature, if you know. So that is what persistence is, maintaining access. That is the main objective of it. So with that, I'll talk a bit about what a rootkit is. I'll just give you a small overview. I'm not going to go in depth on what rootkits does with the privilege levels and how it works in the kernel. No, I'm just going to give you a brief overview. So rootkits. In layman terms, talking about a rootkit is a type of malware. It's a type of malware that the main objective of it is to hide itself. Let's say a normal malware might just try to give you a reverse shell, and it might run some alerts on the soft side of things, on the defender's perspective. You might run some triggers because this is run on the, let's say, user level of the OS. So, okay, from how a EDR works, it hooks every endpoint and then it redirects it to the EDR, and the EDR decides how whether it's malicious or not, a malware, the perspective of a malware. So what happens is things coming from the user object, user uh, level has to be translated into kernel level. In the middle, there's a place where if there's an EDR, it hooks the data coming from the user level and reads it, check whether it's malicious, and then sends it to the kernel level. So what a rootkit does is it operates in the kernel level. So for an example, in layman terms, a malware is like a thief that breaks into your house, steals your things, gets out of there. But a rootkit is like a thief that gets in, steals what they want, only the specific things, and leaves without leaving any traces. So it's like a thief who comes in, breaks in, gets a copy of your key, and locks the door back, leaves like that nothing happened there. But they still have access back into your house. So malware mostly does what a malware mostly does is accelerate data, up files and things like that. But a rootkit, on the other hand, it hides files, it hides processors, and it also allows us to maintain persistence. And malware also allows us to maintain persistence, but rootkit comes to a very deeper level of that. So okay, with that, I'll walk you guys through to the demo. So we might have to start with the demo here and to the demo. Okay. So in this, what I have done now is I have set up two machines. This is a victim machine. This is the attack machine. So this is my local machine. This is the attack server. This is the victim server, and this is a user on the victim server. As you can see, uh, he just is a normal user. No root permissions, nothing. This is root. So I'm just not gonna have a privilege escalation part in this video. I'm just gonna directly go to root and show you how we can use a rootkit in like this scenario. So, because to have a rootkit, you already need to have root access. So, I'm gonna walk you through two rootkits. One, a custom rootkit. The second one, the first one is gonna be dimorphin, commonly used rootkit. It gets detected at most points, but then it's still a rootkit. And a custom rootkit that I customly wrote on like the port back on what was it? Port knocking backdoor. My bad, the port knocking backdoor. So let's go to the example with dimorphin. Okay. So what I'm gonna do now is I'm just gonna set up dimorphin, and so you can have a brief idea of how dimorphin works. So what I'm gonna do here is let's say if I let me see if I have git. Oh my bad. Yes. Once I've been a coffee virus gets installed. Oh my god, what is this? Okay, done. Okay. I've had DigitalOcean servers, but yeah. Okay. We have Git here. Let me get the Git source code from GitHub. T. Okay, what we're gonna do now is we're gonna make the rootkit. Get everything installed. Okay, done. So as you can see, we have made dimorphin.ko. So this is gonna be our rootkit. This is the first rootkit. This is dimorphin. And what we're gonna do now is we're gonna import this as a kernel module. And from there on, I'm gonna show you the functionality of this specific rootkit. Okay. So let me get this sorted in mod dimorphin.co. Okay, we have imported this as rootkit. Okay, so as you can see, currently Samir here has no access to root. He's just a normal user. Now I installed diamorphine in the victim server. Now what can Samir do? Okay, let's say I am the attacker. I have taken over Samir again. I had my root shell revoked. The SOC team of the specific organization found me. They just revoked my shell. I have nothing to do. I just still have access to Samir because they weren't bothered about Samir because Samir was someone who left the organization. They just didn't think Samir would log back in. But then I did. So what we can do now is try to get root. So to do this, diamorphine has specific sets of triggers which we can use to get root. So in this scenario, what I'm gonna do is I'm gonna send a specific trigger so I can get root access to this server. So here, what I'm gonna do is I'm just gonna send this command. So what happens here is my user ID is gonna be 0. I'm still Samir. There's nothing. My UID was earlier 1000. See my ID user ID now. As you can see, I'm root now. No one's gonna know who I am. I'm root. It still shows my terminal in my terminal as Samir, but then I am not Samir. So another thing I'm gonna do here is I'll run a Python server. Python dash http server. Now what I'm gonna do is I'm just gonna send this as a background task, and as you can see, my process ID is 3959. So what I'm gonna do here is I'm gonna just show you here text. You might be able to see this Python server running at 3959. 39. Okay, where's 3959? Let's go 3959. Okay, I can't see this. Why do I not see this? I might be missing this. X. Okay. No, okay. We don't get anything like that. I think I might have just killed okay. Never mind. My bad. I wasn't running this properly. Apologies. Python 3. And you can see I got a shell. Exit. My bad. So I just don't have my glasses on. My bad. I was a bit blind anyways. cdp.server 8080 and that's it. Okay. That's Python. Okay, now you can see 3966. So what I'm gonna do here is I'm gonna hide this process. So to do this, what I'm gonna do is I'm gonna send this a specific trigger with the process ID. So I'm gonna kill dash 31. Yeah, and I'm gonna give the process ID as 3966. Okay, 3966. So I'm just gonna run the previous command. As you can see, the Python process is hidden. No one can see where the port 80 is running from. I mean, you might be able to kill it by just pk Python and it'll just stop all the Python procedures. But then there is the end goal. So okay, this is just hiding procedures. What else can I do here? Let's say I'm in Samir's normal home directory. So what I'm gonna do is I'm gonna hide a specific file. Let's say I'm gonna create file touch hide me. As you can see here, the hide me file is still there. So to hide this, what I can do is I'm just gonna rename this to hide me. I'm gonna make this as prime underscore secret underscore e. As you can see, the file is in, but the file is still there. So this is what a rootkit can generally do. So okay, now that was the functionality of dimorphing. So what can I do with a custom shell, a custom rootkit? My bad. So what I'm gonna do now is I'm gonna import my rootkit to the victim server. I'm just gonna go back. Custom. Custom. Nothing there. And now, okay, I have already built a project in my own local machine, but then I'm not going to use that. I'm just going to upload it back to the victim server and run it there, and then import it back. So I'm just going to send this back. Hold on, CD. This time I just need to change the folder and the folder is custom. Okay, waiting for this to run. Oh my bad, the IPs are wrong. Example.c is uploaded. Okay. Okay, that is also uploaded. Okay. Okay. So what I'm gonna do here is I'm gonna make the specific rootkit. So I'm just gonna give the make command. It's gonna create the custom rootkit. So I'm just gonna go mod example.ko. Okay, okay. And okay, what we have done here is we have made this server vulnerable to this specific attack we're gonna send. Okay, now we are getting a bit of bot traffic, but then yeah, okay, we have got this sorted. Now what we can do here is I'm just gonna okay. So I already custom made the rootkit, send a reverse shell to the specific attacker IP. So okay, now this is my local machine. This is my attacker server. This is my victim service. Okay, victim server in the same place. Okay. So what I'm gonna do here is I'm gonna send HPing to the victim machine, and from there it's gonna send a what do you call it? Root reversal back to the attacker machine. So let me do the H. I'm going to send this HP with a specific payload. Okay. So there's a specific sequence in this scenario, the deadbeef sequence in the packet, and with that, that is going to trigger. Okay. To begin with, let me show you that port 80 nmap dash sc dash c dash p 80 on the IP on our victim machine is already closed. It's closed. You can see it's closed. But what I'm going to do here is I'm going to send this hping command to this victim machine, and from there on, when the specific packet with the specific sequence hits the network interface card, from I'm just network interface, not interface card, it's just network interface. From there, it's gonna go to the kernel level, and from the kernel level, it's gonna set up a trigger to the rootkit where, with the specific sequence is present, the trigger is pushed, and from there we get a reversal to the attacker. So yeah, let me run this. And as you see, I am root at victim. And yes, so that is the basic overview I wanted to show you guys. So as you can see, we send a specific request with a specific sequence, and with that sequence, it what do you call it, triggered and specific trigger. From that trigger, we got a reversal back to the attacker machine. So I might be able to show you the source code for a second as well. So yeah, we have set it up here. Yeah, so there you go. Magic sequence is dead beef. So that is going to be a value in the TCP sequence number, and from there on we are going to be able to get the root shell. So that is what happens in this rootkit. This you can define it in different ways. You can just not get a reversal, or just what do you call it, inject a specific SSH key to the root user as well. Depends on what you guys want to do. But yeah, I mean, that is up to you. It's still up, open to anyone. I'll try to have a link to this specific rootkit as well. But yeah, I mean, that is the functionality of the rootkit, of a custom rootkit and dimorphing. So yeah, I mean, with that we can wrap up the session. But if you want to see how, just want to clarify whether any nmap is gonna trigger this. No, I'll show you exit. I'll send you the same hping. Let me clear this here with a different sequence. Let's say 5 8. Let's start. Run it. You get nothing. You go back and you run the original sequence, and there you have it. So that is the rootkit we made. So yeah, I mean, with that we can end this session, and yeah, that was great. It was a great session, and if you guys have any queries, just hit me up on LinkedIn or just drop me a mail. Uh, Anything would work. So yeah, I mean, thank you, and hope you have a nice day.